All right, the goal here is we're going to draw this out. The secant of theta is 4. Well, what else do we know about secant of theta? Well, its reciprocal function is cosine of theta, which would be the reciprocal, which is 1/4. So I'm going to start by saying all students take calculus. This is where the functions are positive. So if cosine's positive, it can be positive in quadrant 1, it's negative in quadrant 2, negative in quadrant 3, but positive in quadrant 4. The next piece, sine of theta is less than 0. Less than 0 means negative. Well, if everything's positive in quadrant 1, then I know my triangle has to lie in quadrant 4. So I'm going to use this information, the adjacent over the hypotenuse. Now by the Pythagorean theorem, I'm going to find the missing side. So I have a squared plus b squared equals c squared. So I'm going to subtract the 1, and I have b squared equals 15. Therefore, b equals the square root of 15. So this length right here is the square root of 15, and the direction is negative. So my goal is to find the sine of theta. The sine is opposite over adjacent. So my sine of theta is negative rad 15 over 4. We're going to do the same thing here. All students take calculus. Tangent of theta is negative 3/2. So tangent is not negative there. Tangent could be negative in quadrant 2, tangent's positive there, and tangent's negative in quadrant 4. The next part, sine of theta is greater than 0. Greater than 0 means positive, therefore the sine is positive, and I'm going to draw my triangle in quadrant 2. Tangent is opposite over adjacent, so 3 over 2. Now I'm going to give the direction to the 2. So by using the Pythagorean theorem, I'm going to solve. 4 plus 9 equals c squared. 13 equals c squared, therefore c equals the square root of 13. So find the secant. Well, I'm going to find the cosine first. And then once I find the cosine of theta, then I just take its reciprocal. So the cosine of theta equals the adjacent over the hypotenuse. Therefore, the secant of theta equals rad 3 over 2, and it's negative. There's my final answer.